Hello everyone, welcome back to my channel. So in this video we'll solve some more problems on Cauchy's integral formula. As I've told you, this is very important concept, so I'm giving you more examples. So now he has given you this integral and this is the contour, and use the Cauchy's integral formula to solve this integral. So this integral can be split into two parts, e power z dz, e power z by z cube dz, so e power z by z cube dz plus integral c z to the power of 4 by z plus I whole square dz. So I have splitted this given integral into two parts. So we'll take this as I1 and this as I2. So the total integral is sum of I1 plus I2. Okay, right. So first of all we'll consider I1, which is integral c e power z by z cube dz. Okay, so z is equal to 0 is the singularity, right? Equating denominator to 0, you'll get z cube is equal to 0. So z cube is equal to 0, that is z is equal to 0, right? So the given contour is mod z minus 2, mod z minus 2. So it will be 0 minus 2, which is equal to minus 2, which is less than 0. So z is equal to 0 is inside the contour. So when it is inside the contour, then you can apply the Cauchy's integral formula, which is given by f of z by z minus z naught whole to the power of n plus 1 dz is equal to 2 pi I by n factorial into fn of z naught. Okay, so here z naught is 0, and n plus 1 is equal to 3. N plus 1 is 3, so n is equal to 2. So substitute that in this. So this integral value will become now 2 pi I divided by n value is 2, so it is 2 factorial, 2 pi I by 2 factorial into f double dash of z naught. Z naught value is 0. Okay, so we have f of z is equal to e power z. So f dash of z is also e power z, and similarly f double dash of z is also equal to e power z only. So f double dash of 0 is e power 0. E power 0 is 1. Okay, so f double dash value is 1. So what can we write? 2 pi I by 2. 2 factorial is 2 into 1. So 2 and 2 gets cancelled off. So you get pi I. Okay, so this is the value of first integral. Now second integral. So integral c z to the power of 4 by z plus I whole square dz. So z plus I whole square is equal to 0. So z is equal to minus I is the singularity, right? Z is equal to minus I. If you substitute minus I minus 2, so modulus of minus I, as I have told you, its value is equal to 1, because only y is present. So modulus of minus 1 is also equal to 1. So 1 minus 2 is minus 1, which is less than 0. So z is equal to minus I lies inside the given contour. Okay, when it is inside the given contour, then you can apply the Cauchy's integral formula. So here n plus 1 is equal to 2, right? N plus 1 is equal to 2, so n is equal to 1. So z minus z naught, in the standard form you have z minus z naught whole to the power of n plus 1. So n plus 1 in the place of this, it is equal to n plus 1. So n plus 1 is equal to 2, so n is equal to 1. So and the z naught value is minus I. So substituting that, so 2 pi I by 1 factorial, okay, 2 pi I by n factorial into f dash of z naught. Z naught value is minus I. Okay, so we have f of z is equal to z power 4. So f dash of z, so differentiating with respect to z, it will be 4z cube. It will be 4z cube. So f dash of minus I, if you take, it will be 4 into minus I whole cube. In the place of z, just substitute with minus I. So 4 into minus I into minus I into minus I. So 4 into minus plus into minus is minus I into I. Okay, so suppose first of all we'll take these two. Minus I into minus I is I square. I square is minus 1 into minus I you'll get. So again minus into minus is plus. So 4 into 1 into I is 4I. So we have got f dash of minus I is 4I. Just substitute here. So you'll get 2 pi I by 1 factorial is 1 only into f dash of minus I is 4I again. So it will be 8 pi I square. I square is minus 1, so you'll get minus 8 pi. Okay, this is value of I2. So that value of total integral I is equal to I1 plus I2. So it will be pi I minus 8 pi. So if you take pi as common, you'll get I minus 8. Okay. So therefore the integral C e power z by z cube plus z to the power of 4 by z plus I whole square into dz is equal to pi into I minus 8. Okay, so this is how, if you are given with two different functions, you can split that, find the individual values by using the Cauchy's integral formula, and at last you can add them so that you will get the complete answer. Okay, right, we'll see one more problem on this. So evaluate this integral, and this is the contour given for you. Okay, closed contour given for you. Right, so first of all we will find the partial fractions for the denominator. Okay, plus b by 2z plus 1. So a will be obtained by substituting z is equal to 0 in this. So 1 by 2 into 0 plus 1 is 1 by 1, which is equal to 1, and b is z is equal to minus 1 by 2, so it will be 1 by minus 1 by 2, so it will be minus 2. It will be minus 2. Okay, so solve this partial fractions in the method you know. Okay, so you can do any method, you will get the same answers. So this will be 1 by z into 2z plus 1 will be equal to 1 by z minus 2 divided by 2z plus 1. So it will be 1 by z minus 2 by, so it will be z plus 1 by 2. So 2 and 2 gets cancelled out. So what you are left over is 1 by z minus 1 by z plus 1 by 2. So in the place of this we can write this. Okay, so integral C z square plus 1 divided by z into 2z plus 1 dz now becomes integral C z square plus 1 as it is. So 1 by this is equal to 1 by z minus 1 by z plus 1 by 2 dz. So this can be split into two parts, integral C z square plus 1 by z. So z square plus 1 into 1 by z is z square plus 1 by z dz minus integral C z square plus 1 by z plus 1 by 2 dz. So the singularities are z is equal to 0 for this, okay, and z is equal to minus 1 by 2 for this, and the given contour is mod z is equal to 1. So mod z minus 1, 0 minus 1 is equal to minus 1 less than 0. So this is inside only, so we can apply Cauchy's integral formula for this, and this is z is equal to minus 1 by 2, so it will be minus 1 by 2 minus 1. So 1 by 2 minus 1 is minus 1 by 2, which is also less than 0. So this is also inside. Okay, so when it is also inside, you can also apply Cauchy's integral formula for this. Okay, so if you have a simple pole, then what is Cauchy's integral formula? Integral C f of z by z minus z naught dz is equal to 2 pi I into f of z naught. Okay, so this I am applying now, so is equal to, this will be 2 pi I into f of 0, because z naught value is 0 here, z minus 0 we can write, so z naught value is 0 minus 2 pi I into f of minus 1 by 2. So z plus 1 by 2 can be written as z minus of minus 1 by 2. So z naught value is minus 1 by 2. So I have written this. So 2 pi I into f of 0 minus f of minus 1 by 2. So if you take 2 pi I common, so we have f of z is equal to z square plus 1. Okay, so we need f of 0 first. That means substitute z is equal to 0. When you substitute z is equal to 0, its value is 1. Next we need f of minus 1 by 2. So substitute z is equal to minus 1 by 2. So this becomes 1 by 4 plus 1. So it will become 5 by 4. So substituting both values, so it will be 2 pi I into f of 0 is 1 minus, right, so this is 5 by 4. Okay, so 5 by 4, this will be 5 by 4. 2 pi I 2 okay, so 5 by 4, so it will be 2 pi I into minus 1 by 4. 2 pi I into minus 1 by 4, it will be minus pi I by 2. Minus pi I by 2. Okay, so this is how we can solve the question. Okay, right, we'll see one more problem on this. Okay, cos h pi z by z into z square plus 1 dz, and closed contour is z is equal to 2. So first of all we will solve z is equal to 0, z is equal to I, and z is equal to minus I are the singularities, because z into z square plus 1 is equal to 0. Z square plus 1 can be written as z plus I into z minus I, which is equal to 0. So z is equal to 0, first singularity. Z plus I is equal to 0 is the second singularity. Z minus I is equal to 0, so z is equal to I is the singularity. And if you observe, all the three will lie inside only. Okay, if you want you can check also, all the three will lie inside the closed contour. Okay, so first of all we have to take the denominator and find the partial fractions. So this can be written as 1 by z plus I into z minus I. So it will be a by z plus b by z plus I plus c by z minus I. Okay, then a is equal to, just substitute a in order to find the coefficient a, just substitute z is equal to 0. So z is equal to 0 by not considering this, okay. So 1 by z is equal to 0, so it will be I, and this will be minus I. So if you substitute z is equal to 0, 0 plus I is I, 0 minus I is minus I. Okay, so it will be so it is 1 by I into minus I, so it will be 1 by minus I square, so it will be 1 by minus of minus 1, so 1 by 1, which is equal to 1. Similarly b, so when you want b, so just substitute z is equal to minus I by not considering this term. Okay, z plus I is there, so you should not consider z plus I term. Just substituting z is equal to minus I, so it will be z is equal to minus I here. Okay, and if you substitute here, it will be minus 2i. Minus I is minus 2i, so it will be 1 by 2i square, so 1 by 2 into minus 1, so it will be minus 1 by 2. Similarly c, if you have, just substitute z is equal to I by not considering this term, so 1 by I into 2i, so it will be around minus 1 by 2, so 1 by 2i square, so it will be minus 1 by 2. Okay, so 1 by z into z square plus 1 can be written as 1 by z minus 1 by 2 by z plus I minus 1 by 2 by z minus I. So integral c f of z I will take, okay, cos h by z I am taking it as f of z by z into z square plus 1 can be written as integral c f of z into 1 by z minus 1 by 2 into 1 by z plus I minus 1 by 2 into 1 by z minus I dz. Okay, so separating into three parts. First of all, f of z into 1 by z, so f of z by z dz minus 1 by 2 I am taking as it is because it is constant, so 1 by 2 I am taking outside So f of z by z plus I dz minus same 1 by 2 taking constant outside, so it will be f of z by z minus I dz. So all three are simple poles. When you have simple poles, how can you apply Cauchy's integral formula? So integral C f of z by z minus z naught dz is equal to 2 pi I into f of z naught. So this is the Cauchy's integral formula for a simple in singularity or simple pole. So 2 pi I into f of 0 we can write, because z minus z naught is z minus 0 we can write, so z naught value is 0, so I am writing 2 pi I into f of 0 like this. Okay, minus 1 by 2 into 2 pi I into f of minus I you can write, minus 1 by 2 into 2 pi I into f of I you can write. Okay, so 2 pi I if you take common, 2 pi I if you take common, so you get f of 0 minus 1 by 2 into f of minus I minus 1 by 2 into f of I. Okay, so this is what you have to find. So we have f of z is equal to cos h pi z. Okay, so we know that cos hx formula is e power x plus e power minus x by 2. Similarly, cos h of pi z is, now in the place of x you have pi z, so it will be e power pi z plus e power minus pi z by 2. Okay, right, and also we know that cos x formula is e power ix plus e power minus ix by 2. Just remember these two, you can solve easily. So we need f of 0 now. F of 0 is cos h of 0. Because z is equal to 0, pi into 0 also becomes 0. So it will be e power 0 plus e power minus 0 divided by 2. So it will be 2 by 2, which is equal to 1. So when you have, when you want f of 1, f of I, suppose f of I we need. So f of I is cos h of pi I or I pi. Cos h of I pi. Cos h of I pi is e power I pi plus e power minus I pi by 2. So e power I pi, so in the place of x you have pi now, so this will be equal to cos pi. E power I pi, in the place of x you substitute with pi, so it will be cos pi. So cos pi value is minus 1. Similarly, if you find f of minus I value also, you will get it as minus 1. Okay, so just substituting those values here, 2 pi I into f of 0 is 1, minus 1 by 2 into f of minus I value is minus 1, minus 1 by 2 into f of I value is minus 1 again. So 2 pi I into 1 plus 1 by 2 plus 1 by 2. So 1 plus 1 by 2 plus 1 by 2 is 2. So 2 pi I into 2. So the final answer is 4 pi I. So the value of this integral is 4 pi I. Okay, so this is how we can solve by taking the partial fractions and considering each and every singularity separately, like this, each and every singularity separately. So you'll get formula like this. Just substitute in the given function, you'll get the values for these, substitute the values, so you'll get the final answer easily. Okay.